Namaskar everyone. Today I will discuss one of the most important topic of mathematics, that is integration. In integration, we'll discuss today topic integration by parts. This topic is extremely important because it's majority of important questions in your board examinations. But this topic is covering most of the important questions in your competitive examinations around the globe. Those who have not yet subscribed my channel, please subscribe it and share it with others. And press the bell icon so that you come to know about information of latest videos. So without wasting any time, let us start. Just how to solve it? Just think about it. There is always a key. The key term is this one. If we assume this root x, okay, if we assume that root x is some other variable, okay, it can be t, it can be some other variable too, fine. So we are substituting. So basically we are using the substitution method. Okay, and I've explained the substitution method in my previous video, and check in my previous video. When we differentiate it, so we get 1 upon 2 root x dx is equal to dt. Okay, so we have 2 root x, we have dx, so these two terms will give us dt. So this integration will become dt and this will become sine t, and e to the power root x, it means e to the power t. Here we have to apply ILIT formula. Here this word ILIT means I stands for inverse trigonometric functions, L stands for logarithmic functions, A stands for algebraic functions, T stands for trigonometric functions, and E stands for exponential functions. Some people use logarithms before inverse function, but anyway in both the cases your all questions will be solved. You will come to know the answers in every question. Okay, but we prefer this method because this method not only given in your textbooks, but many of the competitive examinations you will get advantage when you use this formula. Okay, this formula help us in choosing the first function. Okay, so this is actually known as product formula. Integration by parts is also known as the product rule of integration. You have to choose the first function according to the ILIT formula. Now, according to this, we see trigonometric function and exponential function. These two functions are given to us. So trigonometric function is given first, so we will prefer to choose the first function as trigonometric function. Now this will be second function. Fine. Here, the formula which we use for product of two functions is this one. Okay, we can say first function into second function, or we can use f into g or u into v or anything else. Fine, but the formula remains same. Okay, this is the beauty of mathematics. Whatever you want to use, you can use, but the formula will remain always same. So first function into second function, integration of this will be equal to first function remains same, integration of second function minus differentiation of first function, integration of second, and integration of this entire term once again. Okay, you can use any of the formula which you like. Now we apply this here. We get first function remains same, integration of second minus integration sign and differentiation of first function. So d upon, remember guys, here the variable of operator is t, so instead of dx we will be using dt. Okay, so remember it. So d upon dt, it means differentiation of first function into integration of second and integration of this entire function once again. The variable of operator was x, so I used x everywhere. Okay, and here the variable is t, so we are using t everywhere. I hope you understand. Now let us see the next term. This is sine t into integration of e to the power t is same term minus integration sign, differentiation of sine t we know it is cos t, and integration of e to the power t is again the same term. One integral is still left. Okay, so once again we apply this formula and we see that this term is first and this term is second. Okay, now apply the same formula. First function remains same into integration of second, integration sign, differentiation of first function, that is minus sine t into integration of second, and integration of this entire term once again. So what we get, this is cos t into e to the power t, minus and minus becomes plus, and this term is sine t into e to the power t and dt. This was I, it means it was the given integral. Okay, so at this place we can always write I. So this is cos t into e to the power t plus I. Okay, so value of I1 is cos t into e to the power t plus I. Fine, so let us put the value here. So we get I is equal to sine t into e to the power t minus, the value of this expression is cos t into e to the power t plus I, and this value should be there in bracket. So when we open this bracket, we see this I is negative. So bringing this I here, so we get I plus I, it means 2I. This is sine t e to the power t and minus cos t into e to the power t. Okay, so we can take e to the power t common, and here we can divide by 2. So we get I is equal to 1 upon 2 e to the power t sine t minus cos t. Okay, don't forget to put the constant of integration. The constant of integration is must. T was root x. Okay, so you have to put this value here, hence I will be equal to, now let us do the next question. Just think here which formula can be applicable. We see that sine 2x, we know the formula of sine 2x, so this becomes 2 sine x into cos x and tan inverse sine x. Okay, so obviously this term is troubling, sine x inside this angle, so we have to assume this term to something. It means again we are using the substitution formula. Maximum questions it will be used. So sine x, so let us assume that sine x is equal to t. On differentiating we get cos x and dx, this is dt. So we see cos x is also here, dx is also here. Okay, and this term becomes integration of tan inverse will become tan inverse t. Okay, and cos x and dx, at this place we will get dt. Now this sin x is left, so we know this value, it is t. So t into tan inverse t. Now see the difficulty level again is minimized. Now we have to use the ILIT formula. So according to ILIT formula, we see this is algebraic function and this is inverse trigonometric function. Okay, algebraic function and inverse trigonometric functions. Among these two, first function we have to assume I. Okay, so this is first function and this is second function. So most of the students do mistake here. They assume this as first function because they want to get rid of this value. Okay, because after one differentiation we know this will eliminate, so they try to take this value as first function, but that is the error. Okay, do not do. According to formula only you have to move. We see first function remains same, integration of second function minus differentiation of first function into integration of second. This is product formula, okay, which we have used here. This is tan inverse t, integration of this is t square by 2. Now remember guys, many times student can write t cube by 3, okay, and this will become totally wrong and you will lead to wrong answer. So this was there in angle, so either you put like this or you can put this multiplication term here. Fine, so these are two options. Now minus integration of differentiation of this term, it means 1 upon 1 plus t square into integration of this, it means t square by 2. Once again integration. Now 1 upon 2 constant is there, we know this can be taken out. Now we have term t square upon 1 plus t square. Fine, so what can we do for this? We can add 1, we can subtract 1. Okay, this thing we can do here to make some adjustment. So when we simplify this expression, 1 plus t square minus 1 upon 1 plus t square. Okay, this we are keeping one function. So this 1 plus t square upon 1 plus t square minus 1 upon 1 plus t square. Okay, so this will give us 1. So we can write this integral in the next step as 1 upon 2 is there are two places. This will be cancelled by this. So we will get of this is 1 minus 1 upon 1 plus t square. Now guys, this is very easy. You know what is the value of this? We get t square into tan inverse t and minus, and what this integral gives? Integration of 1. It means just t, this tan inverse t, okay, plus some constant c. Now the only thing is left, put the value of variable t. So t was sin x, yes, sin x whole square into tan inverse sin x minus sin x and plus tan inverse sin x plus some constant c. Okay, is there any cancellation? No, there is no cancellation, so this is your answer. Basically, in all the questions of advanced like integration by parts and further advanced questions, any previous method can be used. In this question, we have to integrate. Okay, so this logarithmic term is also there, this root term is there, and we cannot apply integration by parts directly or any other method. So we have to first see what this term is, and we have to do some simplification, and then only we can apply any method. Okay, we know that log x to the power m is m log x. So this 2 power, if we want to apply here, it can be applied. Fine. Now one more formula is there, log a minus log b. This is equal to log a upon b. Okay, so we can write this term as log x square plus 1 upon x square. Fine. Now remaining term is root x square plus 1 upon x to the power 4 into this term, and this is operator dx. Now once again, just look at this. When we divide this x square by this term, we get 1 plus 1 upon x square. Okay, this we get inside log. So log 1 plus 1 upon x square. Now can we make similar terms somewhere else? So if we write this x4 to the power 4 as x cube into x, fine, and this x can be written as root x to the power 2, we get x square plus 1, and this term will be x square, and 1 upon x cube will remain as such. So what we have done, we have written x to the power 4 as x cube into x, and this x we have written that root of x square. So here we have got the similar term. Okay, so we have got root 1 plus 1 upon x square into 1 upon x cube into log 1 plus 1 upon x square and dx, the operator. Now just think, what can we assume? This term is there in root. Okay, so it will trouble us. So we assume this entire term here also in log, this term is there. So at least 1 plus 1 upon x square we can think of assuming. When we assume this term as t, so let us differentiate. So we get minus 2 upon x to the power 3 dx is equal to dt. Okay, so do we have this term? Just see, this term we have, dx we have. Okay, so this term will give us the value dt upon minus 2. Okay, so the constant minus 2 will be outside, and this term will become root of t into this term will give us dt, and this is log t. Okay, so now we have got root t into log t. Okay, you may also assume that this term is equal to t square, then you will get rid of this root expression. Okay, and here log of t square will come. Okay, in both the cases you will get the same answer. Again, by ILIT formula we see that this is a logarithmic function and this is algebraic function. Okay, so we will assume this as first function and second function. So let us apply the product rule once again. First function remains same into integration of second. This is t to the power half, t to the power half minus differentiation of first function into integration of second and integration of this entire function once again. So what we get? Log t into t to the power half integration. So this will give us t to the power half plus 1 means 3 by 2 whole upon 3 by 2 minus integration sign, differentiation of log t is 1 upon t into integration of this is t to the power 3 by 2 whole upon 3 by 2. Okay, this 2 and this 2 will cancel, so we'll get minus 1 upon 3 t to the power 3 by 2 and log t. Okay, minus and minus becomes plus, again 2 is there, so with 2 if we multiply, this is also 1 by 3, and in integration we have t and this, so let us combine the powers. So this will become t to the power 3 by 2 minus 1, that is half. Okay, I hope it is clear. This is minus 1 upon 3 t to the power 3 by 2 log t plus 1 upon 3 into integration of this is t to the power half plus 1, it means power 3 by 2 whole upon 3 by 2 plus some constant c. Now let us write the answer. This is minus 1 upon 3 t to the power 3 by 2, it means t means expression 1 plus 1 upon x square whole expression to the power 3 by 2, okay, into log t, okay, same expression. So 1 plus 1 upon x square. See, this expression was given, we can write with modulus or without modulus, both are correct because similar expression was given, so the values of x was already predefined, so this is right. Okay, if you still want to write modulus, nothing wrong, you can write plus 1 upon 3, 3 3s is 9, so 2 upon 9 plus 2 upon 9 t to the power 3 by 2, so 1 plus 1 upon x square to the power 3 by 2 plus constant c. This is your answer. Let us see the next question. Certainly this question is not one of the easiest. Okay, here also tricky method is used. Okay, let us see. So cot inverse and something, we know whenever some inverse function comes, okay, we always multiply with 1. Okay, and according to the ILIT formula we assume first function and this one will be assumed as second function. But okay, see the term, obviously when we apply the formula is not going to be easy. To reduce the difficulty level we have to think out of the box. Okay, we have to apply some different technique to such questions. Okay, so let us see this cot inverse. We can write 1 minus, if we take something common from here, from these two terms, we get 1 minus x. Okay guys, so what is this? I have taken minus common and this has become like this. Now if we write this entire term in terms of 10, okay, so what is the formula? Cot inverse x is equal to tan inverse 1 upon x. So let us apply this formula. This is tan inverse 1 upon 1 minus x. The same term has come into denominator, but look here at 1. This 1 is something specific. We can write this 1 as x plus 1 minus x. Okay, I will say, sir, why are you writing this? Okay, I'm writing this because if we can write at the place of 1 this term, okay, it means if we are writing this as x plus 1 minus x, what is going to happen? Just think about it. Any formula strikes into your mind regarding tan inverse x? Yes, one formula we have, tan inverse a plus b. This is equal to tan inverse a plus b upon 1 minus a into b. Okay, so if we assume this term as a and this term as b, okay, so a plus b upon 1 minus a into b. Okay, so this is actually formula of tan inverse a plus tan inverse b. So let us apply this. So this will become tan inverse a means first term plus tan inverse b means second term. So ultimately what we have done, the difficulty level we have reduced. Okay, now there is only one term or simple term is there in angle. So even if we apply the formula here, the expressions will be easier. Fine. This is in our hand. We could do question from here also, but difficulty level could be extremely high over there. Okay, and here it is extremely easy. This I is tan inverse x integration plus integration of this term. Okay, we know for inverse function when it comes alone we have to multiply by 1. Okay, and according to ILIT formula this is inverse function and this is 1 is considered as algebraic function. Okay, so this is first function, this will be considered second. Same here, first function and this will be considered second function. So here are actually two integrals which we have to deal with. Okay, so let us assume this is I1 and this is I2. So this is our integral I1. Okay, so this is our formula. This is tan inverse x. Integration of 1 is just x minus integration. Differentiation of tan inverse x, we know that it is 1 upon 1 plus x square into x. Okay, so one more time we have to integrate. Now look at this, if we substitute this value as t, so differentiation is 2x. On differentiation we get 2x. So let's multiply by 2 and divide by 2. Okay, so now the differentiation of this function is already existing. So 1 plus x square we assume t and 2x dx is dt. Okay, so 2x dx will become dt and this will become t. Okay, so dt upon t. And what is this? This is just log t. So we have got x tan inverse x minus 1 upon 2 log t. T was 1 plus x square. So let us put the value here, 1 plus x square. Now what is this? This is integral I1. Now we have to simplify I2 and then we have to combine the answers. So here the angle is 1 minus x. Obviously we have to simplify it. So let us assume that 1 minus x is equal to some other variable u. Okay, differentiate. So minus 1 into dx, this will be du. Okay, so dx will be minus du. So this will become minus tan inverse u and this will be du. Okay, now look carefully, what was I1? I1 is the same integral. Okay, and the same integral has given us this output. Okay, this answer. So obviously this integral I2 will also give us the same output except this minus sign. Okay, so this will give us u into, remember the variable is u here. Okay, and here the variable was x. So we have to replace variable x by variable u. So u into tan inverse u minus 1 upon 2 log 1 plus u square. This is our integral I2. Okay, so let us put the value of u. U is 1 minus x. So let us put here. So this is the value of I2. Okay, so what is I1 plus I2. Hence I is equal to I1 plus I2. So what is our answer? I is I1 plus I2. So we have combined both the terms. Okay, but remember this constant C1 and C2, we have to combine them, and C1 plus C2 will become some other constant, C dash or C or whatever you want. Okay, so write your comments on this video and do share it to others. With more tricks and more important questions on competitive level, we'll soon meet in the next video. Till then, take care. Bye bye.